Hello, in this lecture we are talking about data preparation phase to model the data. Uh, Data partitioning for effective model training. Purpose: data partitioning is crucial for building robust machine learning model. It involves dividing your data set into two or more subsets, training and testing. The training set is used to train the model, while the testing set is used to evaluate its performance on unseen data. This approach ensures that the model generalizes well to new data. Common techniques, several popular techniques are employed for data partitioning include first, training test split. This method involves randomly dividing the data into training and testing sets, typically in an 80 ratio 20 or 70 ratio 30. Second, k-fold cross-validation. This technique divides the data into k equals folds, using k1 folds for training and the remaining folds for testing. This process is repeated k times with each loading serving as the testing set once. The results are then averaged to provide a more robust performance estimate. Uh, Second, balancing the training dataset. In balancing the training dataset, understanding the class imbalance. Class imbalance occur when one class dominates the dataset significantly, potentially hindering the model ability to learn effectively from minority class. This can result in model based toward the majority class and underperforming on the minority class. Second, techniques for handling imbalance. Several techniques can be applied to address class imbalance, including first, hours sampling, duplicate instance of minority class to increase representation in the dataset. Second, undersampling. Remove instance of the majority class to create more balanced dataset. Next, uh, synthetic minority hour sampling technique. It generates a synthetic instance of the minority class by interpolating between exiting instance. Next is CRT decision tree algorithm. Classification and regression tree. CRT is a widely used algorithm for building decision tree. It can be used for both classification and regression. Recursive partitioning. CRT operates by recursively partitioning the data based on the feature that best discriminate between class and predict the target variable. This process continues until the tree reach stop Cartesian such such as minimum number of instances in a leaf mode. Gini impurity and entropy. CRT utilize measures like Gini impurity or entropy to assess the impurity of node and choose the best splitting feature. The goal is to minimize impurity at each split, leading to a more accurate and informative trace. Next is C5.0 decision tree algorithm. C.5 C5.0, an enhancement of CRT. A C5.0 is an improved version of a CRT algorithm. It introduced several enhancements, including handling missing value, handling continuous feature, and burning the tree to avoid overfitting. Second, boosting and pruning. C5.0 incorrupt boosting techniques to improve mineral accuracy. It also includes burning techniques to remove unnecessary branch and nodes, leading to a more compact and interpretable tree. Third is real-world application. C5.0 is widely used to various applications and include credit risk assignment, customer segmentation, and medical diagnosis. Its ability to handle complex data set and generate interpretable results make it valuable tool for decision making. Next is building random forest in Python. ensemble, ensemble, ensemble of decision tree. Random forests are powerful ensemble models that leverage the strength of multiple decision tree. They create a forest of tree each trained on a random subset of the data and feature. The final prediction is based on majority vote for classification or average. And for regression of all trees in the forest, random sub-sampling and feature selection. Random forest introduce randomness in two ways. First, bagging. Each tree is trained on a random subset of data, promoting diversity among the trees. Random subspace. Each tree is trained on a random subset of a feature, encouraging the exploration of different feature combinations. Improved performance and robustness. This ensemble nature of random forest lead to significantly improved performance, particularly in terms of accuracy and robustness to our fitting. By averaging the prediction of multiple trees, they reduce the impact of individual tree errors and enhance model generalization. Thank you.